I'm Anil Kumar, sharing with you test questions from my students' test paper. So we have two communication questions on this page. I would like you to copy these questions and solve them. We'll discuss them one by one, right? So the first question here is about the second derivative, which says if second derivative is 0, then there will be no local extreme at x equals to a. Is this statement true or false? If this is true, explain. If it is false, give a counterexample to disapprove. The second part is sketch the graph of f of x based on the information given in the table. So you can copy this information. In different intervals, we are given the value, whether it is positive, 0 or negative, for first derivative and second derivative. From there, you need to sketch the graph of the function, right? Now, let us discuss the first one in this particular video. So it says, if second derivative is 0, then there will be no local extreme at x equals to 0. Is this statement true or false? Now, one should realize that whenever we are finding second derivative, when we say that the second derivative is 0, what are we trying to test? We are actually trying to test concavity, right? And from concavity, we are trying to figure out if we have point of inflection or not. Point of inflection. So the second derivative equals to 0 tells you type of concavity and point of inflection, right? That is what second derivative tells you. Now, this is one way. The second time when we use the second derivative, in that case, we are not checking for 0. We are checking whether second derivative is positive or it is negative, right? And we combine that with the information about the first derivative. That first derivative is 0, right? So if the condition is first derivative is 0, then to confirm for local minimum and maximum, we are looking for second derivative. And in that case, we say if the second derivative is positive, that means it is concave up. And if it is concave up, we have minimum. So that is a local minimum where first derivative is 0, not the second one. Second is positive. And if second is negative, then the graph will be concave down and we have local maximum. You get the point, right? So let's get back to our question. It says if second derivative is 0, then there will be no local extreme at x equals to a, right? So x equals to a is basically at x equals to a at any point a, right? So the critical point is a for us. As an example, we can always take a case of cubic function, right? X cube. So we know x cube, right? This function. Simple. We have f of x equals to x cube. First derivative is 3x squared and the second derivative is 6x. Now at x equals to 0, the second derivative is 0. Do you see that? Well, the first derivative is also 0, at x equals to 0. Now since the second derivative is 0, we cannot confirm local maximum minimum. It is 0, right? So this is actually, once you analyze further the second derivative for this function, then you can say what this point really represents, right? But clearly this does not represent local maximum or minimum, right? Therefore, we can now conclude that if the second derivative is 0, then there will be no local extreme at x equals to a, and that is always true, right? So that is true. So that is how we could actually answer this question, right? So we don't really have to give a counterexample for it is false. But anyway, it is always true that if second derivative is 0, we are not looking for local maximum or minimum. Second derivative should be positive or negative, and first derivative 0 for local minimum or maximum. I hope that helps. Thank you and all the best.